Okay. So as usual, after a test, sort of a break. Well, this one a little more than usual since I totally forgot last week, but another Monday holiday. So um, the plan for today is to just go over the answer key, and this is on. I posted this. It's on La Lima. Um, High was 22, low was 10, average was 16. So I mean, you add 6 to 16, you get to 22. You take 6 away, you get to 10. So um, kind of pretty good statistics for such a small class. My feeling with this is, no one got a perfect score, so it was still good enough, like challenging. And then no one's getting, like, and believe me, I've had it happen in really large classes. You get all over the map, but it's essentially multiple choice. So if you're only getting like 5 right, then you really have no clue what's going on. So I put the ballpark curve on La Lima. You should be able to go on the left-hand side of the tools and pick on it. I don't know exactly what it looks like as a student because I'm an instructor, but this is copied in from what I put in there, and it's roughly ballpark. This is the minimum percent for an A, and it might go down or up a little bit, but also you'll have a better idea of where you stand. Everyone's different, but after the next exam, because you'll drop your lowest exam score and just keep your best 2. I really don't usually give Fs, so that's why the D range is pretty low, and then the F even on there too is there's really no point, I think, in giving someone an F just unless you want to just ruin their GPA, because a D you have to retake the class anyway. But I don't see anybody getting that. I think the lowest grade in the class will be a C. So everybody looks like they're competent enough in getting it, and will do fine in the next class. That's my sort of feedback, input, thoughts on the situation. And it's kind of shaping up where, like, the top third of the class will get an A, the middle third a B, and then the lower third a C, I think. So, but it's been a long time since I've had a classes this small, so it's a little new to me too. Okay, so let's go over the answer key, and then I forgot this somehow got deleted here, number 1. But the core electrons are just to the previous noble gas. And let me pull up the periodic table for the version that I keep or have. The sharing is so annoying. Right, so the core is the noble gas before whatever element you're interested in. And in this one, it was phosphorus here, 15th element. So the noble gas before it is the core, so neon. So 10 was the answer for that one. Maybe we'll need the periodic table again. We'll see. Number 2 here was pretty similar to, I don't know, one of the worksheets or the study guide. I forget which it was, but the concept here was that gases that are in the same container have the same kinetic energy. And then 2 gases then that have the same kinetic energy, their kinetic energy, like momentum, maybe you've seen in a physics class, is a function of the mass and also the speed by the 1/2 mv squared. And you lose the 1/2 since it's equal, so that's why it's left out, right? If you have the same mathematical function on either side, there's no point in keeping it in there. And so in this one, they give you the speed that helium's moving, and it's, except for hydrogen, the lightest element. Then it gives you another gas, and this is a good problem you might see again on the final, just with different gases. So this relationship too is in inverse, whereas one goes up, the other goes down, that we've seen before this semester, and you'll see it again next semester as well. So you were expecting a lower value because it's a heavier element. So answer B makes no sense. Then the other ones are reasonable, and you can tell here I certainly wasn't trying to trick anybody with rounding. The answers aren't close. And the math is pretty straightforward. 3, this one we hadn't quite got to in class, but this is typical in the world of academics, is sometimes they'll give you a problem that is just beyond what they covered in class and see who can make the connection. So we did cover, that electrons are moving, and that's where ions get their charge. So if you went and found the electron configuration for calcium, and if it's a 2+, then there's 2 electrons missing, and that should be the noble gas before, which in this case is argon. And then I think people finished in time, so I think I made this one a touch easier. There was a few easy, or maybe not easy, but no math, not long. Either you kind of know it or you don't, or you go with your gut, or you dug through your notes. Compounds that contain sulfur and nitrogen, when they undergo combustion, whether it's in the air or in a fuel or whatever, they then form the polyatomic ions, and the counterions to acids that deliver the H+, and that's where acid rain comes from. 5, the following reaction is best described as, we did lots of combustion, right? When we did balancing chemical reactions, combustion was always one that was on there. It was on the last midterm. Then the next chapter was heat, and then the chapter after that, or maybe I'm flipping those two, I forget the order exactly, but gases and heat. So we've been covering all these things, and especially the chosen gas here. This is methane, or commonly known as natural gas. It's definitely not endothermic, right? You cook with it. The heat that comes off cooks your food, or warms your house, or heats water to take a shower with. Elimination and hydrogenation were just sort of, they're not made up, they're real terms, but they were just thrown in here. And certainly there's enough info, since we've covered this reaction these types of combustion reactions pretty extensively the last 3 or 4 chapters. And the heat comes off. So that was the key thing from that energy chapter. So it seemed like a reasonable quick check mark type of problem. 6, we've got a gas cylinder, 57.5 milliliters, has a pressure 2.3 atmospheres and a maximum compression at the volume reduces to 16.1. What is the pressure? So this is the classic, if you want to, PV equals nRT, where N and T aren't changing, right? There's no mention of those two. So that shortens to just P1 V1 equals P2 T2. Pretty similar, near basically identical to the dilution equation from last exam, M1 V1 equals M2 V2. And in this one, you didn't have to do any unit conversion, right? It's in atmospheres, and then all the answers are in atmospheres. This is, again, that inverse relationship. So as one goes down, the other goes up. Our volume here decreased, and that means the pressure has to increase. Like, even if you didn't want to, pull out your calculator, round this down to 15 and this one up to 60, and it's about 1/4. So the pressure should increase about 4 times. So 2 times 4 is roughly 8. So if I was just glancing at these before you pick up your calculator, A is reasonable. B is gone the wrong direction. C is bigger. It's gone the right direction, but it's enormous and it's ridiculous. D is bigger, but it's quite a bit bigger, right? That would be more like 9 times, right? If you just call this 2 instead of 2.3. So you're really just picking up your calculator to check if you knew all that and got that, then you're just grabbing your calculator to check and make sure that it's answer A and not B, none of the above. 7, an element that has valence electron configuration 4s2, 5p, 5. You add the valence, right? Valence means outermost electrons, ignoring the d electrons. So you add 2 and 5 together, that's 7. That's the halogens. And then how do you know what row in the periodic table you're in? That's by the 5. So period 5, group 7, A. So this was basically just pulling up your periodic table and making the connection of where these two intersect. 9, determine the energy associated with a transition. So this is that equation for the hydrogen atom where you have the squared factor. So this one was pretty much just a plug and chug. And usually with this, it's just making sure you do the bookkeeping and get the math and the signs correct. So if I was taking the test, I might say, and unless you love math and are a math quiz, I might save this one for last. And this one didn't have an E, none of the above. So if you had time left over and you're solving with your calculator, you couldn't get it right, you could just start putting in the values and checking them to see if you work the problem backwards. What you might have noticed is that due to the formula, like it's negative, so answer E, C, and A don't make any sense. So that helps, and you'd be down to just B and D. 9, 9 is just making the problem above sort of a 2-part, right? So it wants to know what wavelength of light, right? So this is our classic, a firework goes off, an electron is excited, and then when it drops from 3 to 2, that energy comes off at a specific, the light that comes off is at a specific energy. You find that energy above, and then that energy correlates to a specific wavelength of light from the HV. And HV is something you'll see on and off, not just in a chemistry class. If something is caused by light in physics or engineering, you'll see, any science class, you'll see that HV quite a bit. H is Planck's constant, and then this is just the speed of light where you've rearranged the equation because what it's interested in here is the wavelength. And then they're all in nanometers, which is, again, back to the concept of a firework. A would be UV light. So if the other thing to do is if you just flip through the notes or the slides, you might have found the slide correlating to this and seen that it was in the visible range. And so A doesn't make any sense, and D is infrared. So only B and C would make sense, but you wouldn't know exactly which one unless you crunch the numbers and do the math. And E, none of the above was always there. So, well, not always there, but it's there in some of the problems. So 10's one of these from the heat. So this one has lots of little tricks that get people sometimes, but I think this one was on a study guide or in the book or in the slides. I mean, I don't think it was a worksheet. I forget exactly where it came from, but it gives you the reaction. And I don't know the lab or if everyone's taking lab or exactly everyone's situation, but this is a common lab experiment where you take dust, metal dust like this that kind of looks like baby powder or something, and you put it in a little bit of acid and you see the hydrogen evolving. All right, so they told you how much is coming off. It's in 100 mils. They tell you this temperature change and then the specific heat of water. And it wants to know the heat per mole. That's how these things are always reported. So the heat in the reaction is due to MCAT of the water, the 100 mils that it's in. So our temperature change here, it went up in temperature. That means the heat's coming off. So the sign should be negative. So that would eliminate answers C and D. So there's lots of little tricks as I'm going through, I'm trying to point out that could help when you see a similar problem on final. Right, so C and D don't make any sense. You wouldn't know the size of these unless you've done the problem before, which they're pretty different in size, 7 versus 200. Okay, so we got our temperature change. We know the specific heat of water. We know that there was 100 grams. So we can find the heat via that information, just plugging into the MCAT. That gets us to 3,906, which moved the decimal point over, but ballpark 3 kilojoules. But this wasn't for a mole. This was for our 0.38 grams. So you needed to go to the periodic table. The mass is 24.31. Then that is how much heat we got off for this amount of a mole. So if we divide those two numbers, then we'll get the amount for 1 mole, which is then, and this is how all these things are reported, is so that you can use this conversion factor depending on how much sample you're using. It's always on a per mole basis. All right, then, obviously I'm not trying to trick by rounding. I didn't put, minus 204.5 in here. So sort of another one that's a lot of calculations. They're all worth 1 point. So again, if I was taking the test, I would save this one for later, because you can see like the next one here, the complete electron configuration of silicon. You just go to where silicon is on the periodic table. It's right below carbon. It's in the P block, the second element over, and it's in the 3rd row. So anything to this P6 is the core. So this is the core for all of these. You don't even really need to focus on those first 3. It's just the last ones, right? So B is missing, has too many s electrons and no p ones. That doesn't make sense. You can't put 4 electrons in an s orbital, so that doesn't make sense. C has too many p electrons. This would be 2 elements over from silicon, which would be what, chlorine. So that's not right. In this one, there's an electron excited from the s to the p. So that doesn't make sense either. And the same kind of excitation here. So the only one that's even written properly is A. And there wasn't an E, none of the above. So 11 surely would take much less time than, the 2 above. Well, 3 if you count 8 and 9 as separate. 12, a mixture of gases has a molar mass and occupies a volume 56.2 and occupies a volume of 3.78 at STP. The sample is made up of blank grams. So it told you the grams per mole. The STP, whenever you see that, this should ring in your head. So by this amount of volume, they're indirectly giving you the moles. Arrange the conversion factor here. So your liters is on the bottom of 22.4, right? So we divide those two, it cancels. We get 0.16875 moles. And then we already knew that, or they told us what the molar mass is, however they got that number. Again, more dimensional analysis, right? You're in moles now, so we want moles on the bottom. So this one stayed the same. This wasn't given to you because it was a common, it was the whole point of a significant point of the chapter on gases. And then just rounding. So for this one, there's really no, you got to either be really good at math or, this one's difficult to arrange these. You just have to get out your calculator and do it right. And no real way to check your answer since there's a none of the above. But the 1 mole to 22.4 wasn't given in the problem, but if you knew that, then there's only a couple ways to treat these. You can only flip conversions, one way or the other. So, and since there's 2 of them, it's rather binary in that sense, a double binary problem. 13, heat of combustion, and then these are the heats of formation. So I didn't give you the balanced equation, but wasn't it above? Methane wasn't a problem 2 or something? Yeah, I mean, it was actually done above. So you had to balance it, but it was actually given balanced in a previous problem. So I copied it in here, but there is no value for oxygen. That's why I was intentionally left out, because these formations you can kind of think about like monetarily, so to speak, right? Oxygen on Earth is just in the air. You don't have to do anything to get it. So that's why the value is 0. So the 2 in front doesn't matter for it. And this is the reverse of the equation above, right? Carbon dioxide and water going back to form natural gas and oxygen. We burn the methane, the natural gas, for the energy. So obviously the energy comes off when you're cooking food. So the energy is going to go back in, which means this one had to be positive. And A and B are negative, and so is D. So A, B, and D don't make any sense. That can't be the answer. So if you just made the connection that this is the opposite or reverse of a combustion reaction, the answer has to either be C or none of the above. And then you need to balance it, which since oxygen was 0, it didn't really matter. The critical thing was don't forget the 2 here. So I would imagine that would be the major pitfall, but on these multiple choice type tests, I don't see people's work to know what they missed. But 14, excuse me, this is a Hess's law one, and with 3 equations, this one's a bit more tedious. So again, if I was taking the test, this one's going to take a little more time than some of these other ones. So I would skip this and come back to it at the end. Here's our overall. And so we're going to manipulate each one. The thing that jumps out to me first is the HNO3 is in the right spot, but a 4 versus a 2. So we're going to multiply that one by 1/2. That's the first thing I notice. All right, then what else is unique? The NO2 here looks unique to me, right? And here's NO2, and that's the only place it is in the other 2 reactions. We already know what we're doing to reaction 2, so we can ignore it. It needs to be on the other side, so we're flipping it, and then we need to turn a 2 into a 3. And you do that by multiplying by 1/2. All right, then once you have that done, it's just getting things to cancel out. So flipping that would then take and multiplying by 1/2 would make our NO that we have become a 3 from a 2. And we need to have that cancel to get 1 NO left over. So we want this 2 to stay the same. So we're not multiplying reaction 3 by anything, but we do need to flip it since reaction 1 is flipped. So that means we'll just flip reaction 1, and then everything else will fall into line. So with these, you just need to find one thing that you're confident that must happen. All right, then once you know what to do, you perform that math on each one of your delta H's, and then you just add them together. So this one, there's really no way to eliminate these. It's a bit too much math, and it's a, Hess's law, heats of reaction sort of puzzle. 15, rank the forms of light according to energy, least to greatest. So not all of the forms were in here. In each one, it was random. The first one, gamma, is definitely the greatest, but UV is stronger than visible. So that's the error with this one, is these two would need to be flipped. B, gamma is the strongest, so it shouldn't start, right? Because since it said least to greatest. So that's what's wrong with B. C, we've gone microwave, IR, gamma. Gamma is the strongest, so it should be over here, like much like it is up in answer A. D, IR is night vision goggles. V, visible is what we see. UV is sunburns, and then X-rays, the blanket they put on you at the dentist or whenever you get an X-ray for broken bone or whatever. So D is correct. And then once you find the right one, you don't really need to, but we're here talking about it. So E, radio waves are weak, and then this one seems to have the same problem, is that the UV is being ranked, stronger than visible, which is not true. 16. I didn't mean for this to be tricky. I don't know how many people missed it. The ideal gas law begins to fail when blank and blank, and so the ideal gas law works, and we could cover it in the chapter in the order that we did, where we don't need to know too much about chemical structure and bonding yet, because liquids and solids don't behave like gases. Gases we can treat by a law and apply it to all of them. And so when does it fail? It fails when a gas starts to get close to a liquid, and we saw this at the end of the gas chapter. So when the pressure is high, and if you've ever refilled a propane tank, you've heard this, you go to the hardware store or some gas stations, wherever you get the propane tank refilled. After they refill it, if you shake it, you can hear liquid sloshing around. And so it's a gas law, not a liquid law. And then what's the other situation where you can turn a gas into a liquid? It's at really low temperatures. And while you probably don't have necessarily experience with that, you've seen water beat up on the outside of a cold drink, right? That's a gas condensing and turning into a liquid. Yeah, so high pressure and low temperature are when a gas approaches a liquid. 17, this was sort of the classic MCAT, not as tricky as the problem above. I don't know if the slides are a study guide, but we saw a pretty similar problem. This one's pretty much just plug and chug. Right, there's your mass, your specific heat, and you can make up the same problem will be on the test, just different temperatures, or maybe not copper, but all you have to do is I can just make up an element, like name it after my dog or something, and write in a different specific heat, a different mass. But it's really just plug and chug, right? And so for this one, right, it had changed 11 degrees up to 0, then 0 to 47. So the temperature change was 58. That, I think, is the most common pitfall here, where if you put in 36 degrees, that's incorrect. It's the absolute temperature difference. So if you put these in Kelvin, then you don't make that mistake, or you can't make that mistake. If you leave it in Celsius, it's possible to make that mistake, but it doesn't matter which unit you use as long as you have the absolute change. With these, you got to be pretty good at math just to take a guess or eliminate them, right? I wouldn't be able to eliminate any of these just by looking. And then I always put at least one, none of the above on the test. Because what's the point of having none of the above if you never use it? 18, which of the following occurs as the wavelength of a photon increases? So this is that inverse relationship. As one goes up, the other goes down. So the word photon's in here, but it's not really the critical thing. This is the equation. I think it was up at the top. Here's our equation here, right? When you have two things multiplied by one another and they equal a constant, as one goes up, the other goes down. So if the wavelength increases, the frequency has to decrease. Another easy one, I thought, flip through your notes, or maybe you remembered it, etc. Which of the following contributes most significantly to the destruction of stratospheric ozone? This was these chlorofluorocarbons. They're carbon-based, but they're gases, and they have different random numbers of chlorines and fluorines on them. These things are banned and outlawed now, and when they get up into the stratosphere, then the energy, this overlaps with lots of these chapters, right? It's gases, but it's also heat and chemical reactions and balancing, and you'll see this again in Chem 162. The wavelength of light gets high enough energy up in the stratosphere that it can break those bonds, and we're about to move into bond strength energy. So it'll become important and overlap again in the coming chapters. 20, I think there's just one of these diagrams on here. So zinc, you go and you find zinc, it's in the 4th row, and it's all the way across at the end of the transitions. Transition metals, it's saying just zinc in the ground state, no ion, no charge, so all the electrons are there. So 4 is, A is obviously the right answer. You start off, you're in the S block, you're in 4, and then remember that there's that contraction, so 3D, and they need to be filled. All the rest have issues that are incorrect. Not enough electrons, not the right orbitals, not filled, etc. Sorry, I'm just moving there. 21, whenever you see STP, that jumps out at you. 1 mole is 22 liters. So this one, 4.78 grams, it occupies this volume at STP. What is the molar mass? So this is kind of the opposite of the problem above, where I think it gave us the molar mass and then asked for the grams. The numbers are different, but it's kind of the same problem, just in reverse. All right, we know how many liters, so rearrange that equation, which means just dividing to get the liters to cancel. And 22.2 versus 22, so it's about 0.1. And then if there's 4 grams divided by 0.1, that means it's about 10 times. So just by glancing at it before you grab a calculator, I'd say the answer should be something like 47. And so if you look at your options here, A obviously jumps out. So I'd say before I pick up a calculator, it's either A or E, most likely. If you were crunched for time or something, or you fly through the exam and like underline your favorite answers in case you run out of time later, that's what I would have done for this one. But then once you pick up your calculator and do the direct specific math, and again, you can tell I'm not trying to trick people by rounding. 22, more unit conversion. This was a pretty easy one, given gas pressures. 89.3 psi. What's the pressure in millimeters of mercury? So just a couple of manipulations to do here. You can, if you rounded this off to 15 and 90, what is that? That's like 6 times. And then the math's a little hairy to do, but 6 atmospheres times 6 times 760, it's going to be a pretty large number. So I know it's not A, that's ridiculous before I pick up my calculator. B is tiny as well, right? It's over 1 atmosphere, it's 6 of them. So 6 times 760 is much bigger than answers A and B and D as well. And then C is enormous. So for this one, you really don't need a calculator, right? So ballpark again, 90 divided by 15 is 6, and 6 times 760 is going to be in the thousands. And here's it specifically worked out, but I guess D would be the most reasonably close, but C is a million. That's a where the answer is close to like 5,000 versus a million. And then these other ones, they're not even 1 atmosphere. So that's one you could do without a calculator, even though the math isn't too hard. 23, I think this one was on a worksheet, I forget. But just move across the periodic table. So 1s is hydrogen and helium, then 2s is lithium, and you move across. You fill up the 2s, and then the electrons want to be alone in their separate orbitals. That's that Pauli exclusion principle. So you don't fill up identical or degenerate orbitals, you move across. And this will be important later. We just got to covering that this is the way it is. We haven't seen how they prove it or how it's useful. And so that was nitrogen. 24, short-handed electron configuration for gallium. So you go find gallium on the periodic table. It's in the P block, the first element in the P block in row 4, period 4. So the noble gas before it is argon, so that makes that correct. So you would eliminate A there. You will need to move across the periodic table to get to it. So 4s2 3d10 is correct. So C would still be correct, but D wouldn't, right? There's an 8 there. It should be a 10. And then C has 1 electron too many. So correct answer is B. We didn't actually do this demonstration, obviously, in lecture, but this is one of the kind of cooler ones I used to do. Is I would bring liquid nitrogen to class, and we saw this in the slides where we covered where it would take a balloon and put it in ice water, but ice water is only 0 Celsius. It's not that low. Liquid nitrogen's a much greater temperature change, and you can see the balloon shrivel up. It's not exactly perfect because you're relying on the rubber, but it's good enough to prove the point. So room temp to liquid nitrogen, that's your temperature change there. These need to be in Kelvin. So if you didn't put it in Kelvin, you're obviously going to get the wrong number. But then this is that PV ideal gas law moved around. PV over NT equals R, the constant. And then there's no it's a balloon that's tied in a knot, so there's no gas escaping in and out of it. So N is kept the same. The pressure on the outside is 1 atmosphere, and since the balloon's made of rubber, that in theory doesn't change because the rubber can expand and contract, assuming it's perfect. So those two are left out, then the only thing left behind is V and T. And so we've got one situation, 1 volume, 1 temperature. And then the next situation, we've got T2. So rearrange to solve for V2. And I don't know why I have a 0 there. But anyway. And then this is a good one. We didn't do it in class, but you saw it in the slides. But when you actually do it in class, we didn't measure, I don't know what the balloon actually is, but you see the balloon shrink. So that they're directly related. So you're looking for a smaller number. So A doesn't make any sense. B is going the right direction, but if you've had a lab or done anything at all, right, you move the decimal point over 3 for milliliters. 3 milliliters is an incredibly small amount that's like a bottle cap of water or something that's less than that. And then C here is again going the wrong way and quite large. So from these, D is the only one that would make sense. So another one where if you know the trend of what's going on, you could eliminate A and C for sure, and B's pretty ridiculous. And then you're just between D and E. Okay. Okay, so I know that that's a touch short, and then plus with Kuhio Day, this is a fairly nice little break from Chem 161, but I'm sure you have other classes and exams and things to study for. But we'll pick back up and finish up and start in on 8, and chapters 9 and 10 are pretty long, and we sort of shift gears. 9 and 10 are really like one big large chapter, and for those that are bio majors and you know you're going to take OChem, this last part of Chem 161 is really the beginning part of organic chemistry. Chem 162 is a bit more of math. It's kind of more for the engineers and physics majors a little bit. Sorry, I'm just pulling something up that'll be helpful. Yeah, so our coming chapters are bonding and how molecules attach. And that's all organic chemistry is carbon-based molecules attaching to each other. So you can't understand all the odds and everything there is to OChem, to organic chemistry, if you don't know how carbon bonds and makes molecules. So if you're at the junior college here, it doesn't really have your specific major, and it shouldn't, but if you're engineering, math, something like that, and you know you're not going to take OChem, then somewhat doesn't apply to you. Sorry, this is what I wanted to pull up. Shrunk in size. There we go. Okay. But if you know and you're committed in a bio major, go on to Amazon, and it doesn't matter which kit you buy. Looks like these ones are all the stick ones. These ones are all the ball and stick, but there are other ones. This is the one I bought in undergrad. They still make it. This one's a little expensive. It doesn't matter which one you get, so I wouldn't buy the expensive one. This is kind of a bigger blow up of what it looks like. Well, the ball and stick one's really popular. This one's a little different here. This is the sticks are a little bit bigger and the balls or spheres are a little bit smaller. It doesn't matter which one you get, but if you know you're going to take OChem, these things are like, and you can find a little bit cheaper ones. It's like 15 bucks, 20 bucks. And especially if you're a person that doesn't see things well in 3 dimensions, this will be really handy for our coming chapters in about a week or 2. So I'd highly recommend if you know you're going to take OChem, and I would suggest taking, if you are one of these people, I would suggest taking Chem 162 over the summer somewhere and then taking OChem in the fall. The sooner you take these things when they're fresh in your mind, the easier they are. The end part of Chem 161 is the foundation for organic chemistry, and if you wait till fall to take Chem 162, then you're not going to take OChem until next spring. And when we're learning it here now in April or May, you're not going to think about it again until the following January. And I'm assuming nobody loves organic chemistry. You're doing it to take it and get it over and out of the way. So just my 2 cents / recommendation, etc. Okay. So that's all I have planned and want to cover for the day. We'll pick up here. I hit the button. So if you want to unmute and ask any questions, um, or if you have questions on the test, you can email me. And you know, unless you want to do it here in class or whatever. So, questions, comments, thoughts, feelings. If not, then
I have a couple questions.
sure.
The final, oh, can you hear me? Sorry.
Yeah. Want me to
The
pull up
final,
or is it just general?
no, just general question.
Okay.
So the final exam, is that going to have new information, or is it just the information from the first 3 exams?
It'll be like, it's twice the time. It'll be 2 hours. So it'll be like a midterm on the last stuff we cover, and then a midterm like reviewing the stuff we've already covered. So I'd say like 7 problems from each midterm. We have one more midterm, and then like a separate midterm. So probably 50 questions. So like 25 on the stuff we cut that we didn't get to before this last midterm, and then 25 questions of review on the things we've already covered.
Okay, so about half of it will be information that wasn't on the first 3 exams.
Yeah, ballpark.
Okay, and then so if we get an A on the final, then we get an A in the class, right? You'd said that.
Yeah, sure.
And so what if you get a B on the final and an A on the first 3? Does that count as the one that gets dropped, or like how does that work?
Well, the midterms are all the same score wise, and so I'll drop one of those midterms. I'm not going to drop the final, and you wouldn't do the final's worth more points, so you don't want the final to be dropped, right? Because it's twice the number of points, so it'd be almost impossible to do worse score wise on the finals than on a midterm.
Okay. And so basically if you want an A in the class, just get an A on the final. And
Yeah,
the first 3 are used to kind of
in my experience, people who get A's on the final were already getting an A in the class, but it is possible, it happens every now and then, where someone's, you know, B or C or something, and then, you know, improves. But it's hard to improve late when we're constantly covering new chapters and new material, etc. But yeah, it is possible.
Okay, and then my last question was, so you would put in the chat that an A was 80%, B 60, etc. Is that the same? Is that just for this last exam, or was that the same scoring for the first exam?
It's the same one, but this is a rough estimate. Like I might tweak it and higher or lower. You know, usually with these things, I'm more firm on them when I have a class that's like hundreds, 200 students. You know, like statistics and numbers work out better the larger the sample size when it's a smaller class like this. And I haven't done a class this small in a long time, so you know, this could go up or down a little bit. So don't, you know, hold firm with it. And then after, I'll probably just leave it the same after the next midterm, but then you're going to drop your lowest score. So the percentage will stay the same, but your score should go up because you'll drop your lowest midterm. So.
Gotcha.
Yeah.
Okay. Perfect. Just seeing all the ways I can keep my GPA and maintain an A. So
yeah, no worries.
Thank you.
Yeah, cool.
Okay. Have a good day.
You too. Thanks. Bye.
Mr. So I just have like a follow-up question regarding the like the exam, the final exam. So you were saying that the exam will be like sort of like cumulative exam, like covering materials from the beginning of the term.
Yes.
Is that something like that? Okay. Yeah, got it.
Yeah, so the first 2 chapters were pretty easy stuff, right? There was like, just changing temperature, like, like if you go back and look at the first 2 chapters, usually you think like, wow, that was really easy. It's
Mhm.
not really chemistry. So it'll focus more on sort of chapters 3 through 10, and we
Okay.
certainly won't get to finish 10. And so 10 or the second half of 10 there'll be a stronger emphasis on that stuff that we cover on the final, since there wasn't a midterm on it. But
Okay.
but it will be cumulative overall.
All right. Got it. Thank you.
Yeah.
Yeah. I think that would be all. Thank you, Professor. See you
All
next
right.
week.
Cool.
Okay.
See you Monday.
Yeah. Bye-bye.
Hi, Professor.
Hi.
So I sent you an email a few days ago for the Chem 162 class. On my end, I still can't access it on Lima. So I was wondering if you could send me the Zoom link for tomorrow's class so I can
Here's-
attend it.
Yeah, hold on. I tried that. Something's up with my email. Like it's not linking. I got a new phone and it's not linking to my phone. Let me switch. I have Lima open though, and I did that. And let me see if it manage participants. I have you on here as a teaching assistant. It says you're on here now.
Okay, let me view it.
Can you go to your Lima and see if it's there now?
Yeah, 1 second. I gotta log in.
Yeah.
Oh, okay. Yay, it popped up.
It's there? Okay. Yeah, I didn't see your email. I don't know what the deal is. It's like, I don't know. I gotta figure out the settings on my phone, or just it doesn't buzz and remind me in Bing or whatever. But I should certainly just check it myself anyway. But nice to meet you. This is weird to me, as I'm sitting at home in my room and everyone else is like on campus and sees each other. But it's still fun. So
It's definitely interesting doing Zoom through doing class through Zoom. So
yeah, it's got its pluses and minuses. I really don't like the testing format. But it is what it is. So
are you sending them to the testing center on campus, or is it all through?
no, I've been
Proctor?
just doing it through Lima. So
Okay.
I'll send you I'll send you the link tomorrow when I start the 162.
Okay.
Hopefully I don't forget. It's on the syllabus that's on Lima on there. But I did that today. I sent you the one for this, but it seemed like you already had it and knew about it. But I'll send you the one for tomorrow.
Okay.
Yeah.
Thank you.
All right, cool. See you tomorrow.
Bye.
Bye.